Hi, my name is Adina, and in this video I'm going to explain to you how you can customize your WHISKiT physics simulations by adding and manipulating objects in the simulation environment. So again, here is the GitHub repository. Assume you've installed it and everything is working. So I'm going to head over to my code editor, and here on the left side you see the repository directories. And the most important thing we talk about today is this simulation.cpp file in the source folder. This file contains two main important functions. So the first one is the init physics, which is used to set up your simulations. So there you will add objects so you can use them later in the simulations. Then the second function is the step simulation function. This function is called every time step in the simulation. So you are able to manipulate your simulations basically in real time if you want to by making your changes in this step simulation function. So let's go to the init physics function. So the first few lines you really don't have to worry about. This is all to set up the solver. And then you see three sections, or one section where all the three example objects are created. So the first one is a peg that we have in our default examples. We have a wall and we have a 3D scan. So you can use these three sections here as a template if you want to create your own objects, or if you want to load your own objects. So if you want to create a peg, for example, and we are using here a cylinder function that is from the bullet physics library. I recommend to check out what the bullet physics library has available in terms of different shapes. There are squares, cylinders, spheres, and I think also like half spheres and stuff like that that you can use to build your own simulation. Also check the documentation with like what these parameters are. I'm not going to talk about that. You can check that out yourself. But in any case, what you need to do to create a custom shape, you will have to call one of these functions to create the collision shape. You will have to set a collision margin, which I've found 0.1 works fine for these type of simulations. And you have to add it to the collision shapes vector. That's important that your solver knows about that shape. You define a coordinate frame for your shape. You can set it basically to 0 to place it at the origin, and you create a dynamic body from it, and you don't really have to worry too much about these parameters, but if you want to, I think you'll find them in the simulation utility. You add a rigid body created from that particular shape, and keep these parameters the same. They won't change if you want your whiskers collide with the object. You also have to activate it so it's considered for the collision detection. So that's how you would create a peg from a cylinder shape that is vertical. Here the wall is created, is the same process, but it's basically, we're using here a box shape to create that wall. Then you also have the ability to load in a 3D scan, which is like a custom C++ object that we created. So this object here, you can view it here if you're interested in the details. But what you need to know, you need to define a path where you have stored your 3D scan. And you can also see that in the parameters here. You have file environment, and you define the 3D scan, which has to be an object file. Otherwise, you have to write your own function, how you load it in, and that's pretty cumbersome. So save your 3D scan in an object file and define the path here to load it into the simulation. Then once you've done that, you're pretty much set to go, but you can also change velocities, for example, in your step simulation. And you have an example here for the moving peg in the passive simulation example. So this here basically shows how you define a velocity. Here we have particular speed, and we scale, we use that to scale the velocity vector here. Basically that defines the direction, and then you set the linear velocity. But it doesn't have to be constant across the entire simulation. So you can also manipulate that in each time step. So you can use a function or whatever to calculate the current velocity in each time step. Yeah, so you can also, if you want to, we don't have an example of that here because it's also individual what you want to do, but you can use this section here, parameters exploring, where we have basically started, but it's not completed, how you can move the rat head as you like during a simulation. For example, you might have a head trajectory from tracking an animal in an experiment, and you would like to make your simulations follow that path. So this is an example here how you can set the linear velocity of the rat head and the angular velocity, but you have to obviously read in your velocity, the defined current velocities from some file like we do it here. If you have it for the whisker trajectories, we have a CSV file, so you can use the similar process to move the rat head as well. So yeah, that's it. That's what you can do. You can add objects in the init physics. Just follow the procedure that's already here. You can use these templates to create your own shapes, or you can add your own 3D scan. And in the step simulation function, you can manipulate the object velocity as well. Now, if you wanted to have some real-time simulations, like you want to use a model that is reactive to an unknown environment, so it's not deterministic, you will need to manipulate this step simulation function that it will read in the current velocities to change either objects or the whiskers or whatever. And that would occur in the step simulation function if you wanted to do something like that. So yeah, that's it, how to customize your simulations in terms of objects in your environment. So thank you for watching. Bye.